The next problem that we're going to work on is going to build directly off the steps problem. So we're going to take care of it right now while we still have the steps problem fresh in our mind. Inside of my exercises directory, I'll find the pyramid folder and then open up the index.js file. And then of course, we'll also start up our tests as well. So at the command line, just pyramid test.js -- watch. And let's see how many tests we have. All right, so make sure you got about 4 tests running. All right, let's take a look at this. So we're supposed to write a function that accepts a positive number n. The function should console log a pyramid shape with n levels using the pound character. Make sure the pyramid has spaces on both the left and right-hand sides. So this looks very similar to the problem we just worked on, the steps one. However, now it's not only one side that we want to put these kind of spaces on, it's both sides. So we are now forming a pyramid shape. So definitely you can very quickly see why this is very much so similar to the problem that we just worked on, the steps one. So methodology will be very similar, but now it's going to be up to you to kind of figure out some very interesting edge cases around this one. So I'm going to give you a little bit of a head start here beyond the fact, saying obviously go back and look at the code from the steps problem. We're going to look at a diagram that's going to kind of help you focus in on a couple different areas. So we looked at one diagram very similar to this for the step problem. This time around, I've kind of removed some information and changed some stuff around to accommodate the differences for pyramid. So I think that the general algorithm that we used for the iterative solution for steps is still going to work here. So I think that we should still iterate from 0 to n. So n here being the total number of rows that we have. So we'll start off at 0, 1, 2. Then for each of those rows, I think we'll still create an empty string, but now where things start to get really interesting is that inner for loop. So we're going to iterate from 0 to, I don't know, you're going to have to figure that part out. That's going to be one of the challenges here. In addition, once you figure out exactly what bounds you want to iterate to for that inner for loop, you are also going to have to do some very interesting logic to decide whether or not the given column should have a pound. So remember previously it was a pretty easy determination for us. Before, when we were doing the steps, we said if the current column is equal to or less than the current row, yes, we want a pound. So this time around, it's going to be a little bit more involved than that. And I'm going to leave it up to you to figure out exactly how to do it. One tip that I will give you, just so you are aware that this exists, and I really want to just give you a quick example of it. Remember that math.floor is a function. So if you use math.floor, it'll take a decimal number and it will round it down to the nearest integer, in this case 5. So I don't know, maybe that'll be helpful for you depending on how you tackle this, maybe it won't. I just want to remind you that that function exists. So that's what you're going to have to do. You're going to have to do a little bit of work to decide whether or not a given column should have a pound. Otherwise, everything else is going to be pretty darn similar. Now, I do want to focus on one thing here. Remember previously, n was determining the number of rows and columns. But like we just said, now that inner number or that inner for loop or the number of columns is going to be not, exactly identical to 3. So this is an accurate diagram for n3 because we have 3 rows here, but you can see that there's clearly more than 3 columns. And if we start to think about the different pyramid shapes that we might have, I've put some of them together here. Here's the pyramid shape for n equals 2. This one has 3 columns. Here's n equals 3. This one has 5 columns. And then we could go up to n equals 4, and this one has 7. So in each case here, you can see that the number is changing. Yes, it's changing by 2 each time, but I'll leave it up to you exactly how to calculate it. So just keep that in mind. Anyways, give this a shot. Obviously, again, draw upon your experience from the steps problem quite a bit as you're working on this one. I will say that we are going to go over the iterative solution first. So I recommend you put together the iterative solution first, and then we'll take a look at the recursive solution after that. So if you want to just do one or the other, totally fine. I leave it up to you. Anyways, quick break, give it a shot, and we will look at a solution in the next section.